All right, we're going to start talking about acids. Okay, acids are basically very similar to our ionic compounds. For us, when we think of acids, though, we're thinking hydrogen. Okay, they're starting with hydrogens. And it's basically a hydrogen with a negative anion that we've seen. When I say negative anion, I mean virtually any of the negative polyatomic ions and also the negative elements. Now, certain formulas that start with an H aren't regarded as acids typically, like H2O. Just because it starts with an H doesn't necessarily mean it's an acid. For us, that's not going to be overly important. I will dictate, the list of acids, so you don't have to really wonder if it's an acid or not. If I say name the acid, you know that's an acid. Okay, so they're just like ionic compounds, but they're starting with an H. And we'll redefine this a little bit better when we get to more solution-based chemistry later in the year. But for right now, we just want to have a firm grip on the actual naming. Okay. So taking H with, I'm getting a little darker here. Taking H with non-metal. Okay, like I don't know, we'll say an F. This is an acid. And we call this a binary acid. Okay, another example could be H2SC. These are both binary acids. When I mean binaries, I mean it's just a two-atom system. It's H with a negative element, a negative anion element. All right. And now you might be saying, well, wait a minute. Two-atom system. You have three atoms. That doesn't make any sense. Well, when I say two-atom system, I mean it's just two types of atoms, H or multiple H's with another negative element. Okay, and so that fits the bill. These are called binary acids, and for our binaries, okay, for our binary acids, the naming system is like such: hydro blank ic acid. Hydroblankic acid. Okay, and this works every single time. Hydroblankic acid. And what actually goes into the blank is whatever the H is bonded to. So for this one, it's going to be fluorine turns into fluoric acid. For this one, it's going to be selenium turns into selenic acid. The hydro acids are pretty straightforward, okay? Because again, it follows the same exact name every time. You just have to fill in the blank, okay, with whatever that element is. Now, a common question that I receive is, how do I know which ones get the hydros? It's going to be H with something else. For example, we really don't typically see or label H2O as an acid, but there are times when it can fit the bill, and according to our system, it would be perfectly acceptable to say hydroxic acid. All right, and if you Google hydroxic acid, it will come up as H2O. You're never going to see this in my class, but what I'm saying is it's perfectly acceptable nonetheless. So it's hydro, fill in the blank with whatever is hooked up to the H, okay, the negative anion to H, ic acid. And that's the binaries. The binaries are relatively straightforward. Now, the flip side to the binaries are the polyatomic ion-based acids. Okay, so my polyatomic ion-based acids. Most of them are tertiary. Well, what is a polyatomic ion-based acid? It would be H, okay, bonded to a polyatomic ion. And we have a very, very, very straightforward, simple way of doing this. It's 8 ic. You know what? I'm going to go back and forth to this. 8 double-headed arrows, os. 8-ic-8-os. ClO3 is chlorate. ClO3 is chlorate. Well, when it's an acid, we call it chloric acid. And this goes a little bit against what we know from the other naming systems, because it's like I'm ignoring the H. And I'm really not. I'm just doing it a little backwards, a little flipped than what we're used to. The word acid is actually referring to the H. So my H is represented in the name with the word acid. Now, the other acids, the binary acids, had the word hydro in front, and the word hydro designated it as a binary acid. Not only was it an acid, hydro meant that it was a binary acid. It was just H in another element. So because these are polyatomic ion based, they're not binaries, we leave off the hydro. And because this is chlorate, it's considered chloric acid in the acidic form. All right, the sister acid would be ClO2. All right, and with our naming sequence, this is chlorite, so it would go to chlorous acid. Okay, so the acid again was represented by the H, and the 8-ic-8-os rule holds true here. So because this was an 8, it went to an os. Now I put double-headed arrows on this because sometimes it's up to us to go backwards as well. And sometimes that's relatively difficult. You know, we really have to think a little bit. Okay, what I mean by that is, what if you have something like this? And I want the name of that. Well, I realized I'm going the same way. Well, let's name it anyways. First of all, we notice that it's an acid. It's an acid because it starts with an H. Okay, and for us, that's good enough as an indicator as right now. Starts with an H, we're going to consider it an acid. And it's coming from the root, the polyatomic ion is carbonate. Well, carbon 8, we switch the 8 to ic. Carbonic, or carbonic acid. All right, and it's usually pretty much straightforward going from the formula to the name, as long as you know the rule, 8-ic-8-os. Okay, and the example I was trying to show that split my mind a little bit is going from the name to the formula. And I'll tell you what, I want it to scrap box. I'm going to get my final answer box over here. This will be my scrap area. Alright, I'm going to go from the name to the formula. And the first thing I know is that's an acid, because it's blaring out with the word acid. Acids start with an H and they're +1. Acetic acid. Well, 8's went to ic, 8's went to us. I have to go backwards. Acetic has its root of acetate. Okay, if you switch the ic to 8, you have acetate. So we have the acetate ion, C2H3O2. Okay, and that was -1. So first of all, you should be able to spot that I'm neutral. So to actually get the formula, I'm just going to take out the charges. All right, so my acetic acid is an H with the acetate ion. Okay, and we do have a couple of little exceptions. Okay, so if I put my exceptions down, I have 4 of them, and that will be these 4. Okay, the phosphate, the phosphite, the sulfate, the sulfite-based acids. All right, and with our naming sequence, this is phosphate, so it'd be phosphic acid, and the exception would be that we call it phosphoric acid. Okay, so we don't call it phosphic, we call it phosphoric. Okay, the OR from the root word phosphorus. Okay, and the same thing here, and it would be phosphorus acid. Instead of phosphorus, it would be phosphorus. Okay, the OR. Sulfate would be sulfic, but we don't call it sulfic. We call it sulfuric acid. Okay, from the root word from sulfur. The UR sticks around, the OR sticks around. Same thing for my sulfite. My sulfite would be considered sulfurous acid. Instead of sulfus, it'd be sulfurous. Alright. And that's about it. These 4 exceptions will do us well. Alright, so you just have to be a little bit on the lookout for that. And that's about it. So in summation, we had the binaries. Alright, so if I had to just do a quick summary here for my acids, we have the binaries, which was my hydroblankics acids, hydroblankic acid. We had my polyatomic ions ones, polyatomic acids, and our rule would be 8 ic ite os. And you could also draw double arrows because we can go back and forth. 8-ic-itos. Okay, it rolls off the tongue if you say it fast enough. And that would be our acids.